All right, page 86, kinematics. This is motion in 2 dimensions. So this is going to get a little bit more complicated, but remember what Galileo says we have to do when things get complicated. We limit the scope of inquiry. So that means we're going to, in cheap, sloppy language, look at these problems piece by piece. Now on page 86, kinematics, motion in 2 dimensions, we see at the top of the page an example of a rifle. This is a thought experiment that we'll do. So this thought experiment works this way. We're going to imagine a rifle set at a perfectly level aspect, 0 degrees elevation. It's going to fire a bullet, and we're going to rig up a little contraption such that we can put a ball bearing right next to the muzzle of the barrel so that when the bullet exits the barrel, this ball bearing is dropped. And the question is, what's going to hit the ground first? The bullet or the ball bearing? So go ahead and pause this for a minute and think about it. Okay, now you've thought about it. Here's my hypothesis. My hypothesis is that they will land at the same time. Why? Well, because we're talking about motion along this vertical axis or the y-axis. And what are the forces in play along this axis? Well, gravity. So now we know we have an acceleration problem, and if we know that, then we can do an inventory and use our odd man out technique. So here's our ball bearing, here's our bullet, VI, VF, AST, VI, VF, AST. So for the ball bearing, the initial velocity dropping down will be 0. Gravity is set at 32 feet per second squared. Displacement, 4 feet. Time is the question. And final velocity is the odd man out. We don't care. For the bullet, again, keep in mind that we're talking about motion along the vertical or the y-axis. So its initial velocity in this direction is 0. What's making it increase its velocity in that direction? Gravity, 32 feet per second squared. Displacement is 4 feet. Time is the question. Again, VF is the odd man out. You don't even really have to do the formula. You can see that the inventories are identical. So yeah, the answer is they will land at the same time. All right. We can do a little experiment at home with this, and so we're going to pause the video right now, and then I'm going to demonstrate the experiment that will put the hypothesis to the test. So let's pause here.